Today's topic is the scientific revolution. The scientific revolution was basically an expansion of Renaissance concepts of a rebirth of learning. The scientific revolution basically means that today we have to talk about science in history class, and I gotta be honest, Homer seems to share my feelings on that right now. Let me tell you. The scientific revolution was a time period after the Age of Exploration. During the Age of Exploration, European cultures came into contact with places around the world that had great scientific ideas that the Europeans didn't know about, new technologies that the Europeans didn't know about. And they began borrowing some of those ideas. They began improving upon them and coming up with something that would actually work better. It took some of the ideas from the Renaissance and it improved some of those ideas and made them better. Basically, Europeans began adopting things from other groups. Adopting means borrowing, stealing, copyright infringing, however you want to say it. And then they adapted them and made them better to where we still can use them today and have them sometimes actually be worthwhile parts of our lives. Scientific revolution, new ideas, and new ways of thinking. Now, we've got to look at the past a little bit so we can understand the future some also. Like I used to tell my students, the past is the key to unlocking the future. Last year in 6th grade, you talked about the fact that the Catholic Church dominated life in Europe and life in this time period. The Catholic Church did not want people asking questions. It believed that everything had to be accepted on faith. And from a church stance, faith is the key. But scientists want to know why. Scientists want to know how. And during this time period, scientists began to question the accepted answers that the Catholic Church and prior scientists had given, and began looking for proof to things. The church isn't going to be happy about this concept, and on Wednesday, we'll come back and we'll talk about this a little more. I have a cartoon here about a guy named Johannes Kepler, which the state of South Carolina says you need to know about. Kepler came up with the idea, taught the idea, that the planets move in what are called elliptical orbits. Elliptical means kind of like an oval or an egg shape. Up till this point, if anybody thought about it at all, they just assumed that planets traveled in circles. Nice big rings. Kepler's one of those scientists that began to question these things. The most famous example of something that scientists began to question during this time period, though, is what was the center of the universe. An ancient Greek scientist named Ptolemy stated the Earth was the center of the universe, and that the Sun and all the other planets in our universe circled around the Earth. This was called the geocentric theory, from the Greek word root geo, which means center. Catholic priests believed this theory based on a verse in the Bible that talks about how the Earth is the apple of God's eyes, and also another verse in Psalms that talks about how the Earth is not moved. And they believed that these verses were dealing in a scientific concept instead of a religious concept or a loving concept. The fact that we're the very center of God's eyes, the very most important thing to God. And so the Catholic priests were teaching the people that this is the way it is, that the Earth doesn't move and it sits at the center of this giant universe, and everything else in the heavens or the skies circled around us. But a brilliant scientist named Nicholas Copernicus provided everybody with a reality check. He came up with what's called the heliocentric theory, or a theory that says the sun is the center of the universe. Just today in class, I had a student who was able to point out the fact that the ancient Greeks had a god named Helios, who was the sun god, and this is based around him. Galileo comes along later and proves him right using the telescope. And the Catholic Church is going to have problems with this, and this will be a key point to our discussion on Wednesday. All of this brings me to my favorite scientist. Now, I'm not a big science guy in the first place, but Isaac Newton is a scientist that really always has excited me. I don't know if it goes back to the corny little story about the apple falling from the tree and hitting him in the head, leading to him coming up with the theory of gravity, or if it's just his name as a small child, I had Fig Newtons. Now they creep me out. But maybe it was the Newton thing because of that. For some odd reason, I've always liked Isaac Newton. And I'll be honest, I really think he's probably the smartest guy who ever lived. Next to myself, of course, because I'm just me. Isaac Newton was an English scientist, comes up with the theory of gravity, which replaced my favorite discredited scientific theory of all time, the invisible space hooks theory, which said little tiny invisible hooks grabbed you and would pull you back to Earth if you ever jumped or something. In addition to that, he also created calculus, which is big brain, like rocket science math. And I don't use that phrase jokingly. I mean, it literally is science for rocket scientists. In addition to that, he helped come up with the laws of thermodynamics, which help deal with how things fall apart over time. The laws of motion, which deals with things in motion, obviously. Things like that. Really smart guy. Probably Isaac Newton's most famous concept that he came up with, though, is the scientific method. In a lot of ways, it's built on different scientist ideas. But the scientific method is a major contribution of the time period, and it established a systematic way, or a orderly system, to find proof for things using logical reasoning. Faith and the scientific method, they don't work together. Now, that's not to say faith is wrong and the scientific method is right. That's not to say the scientific method is wrong and faith is right. But the scientific method revolves completely around your ability to test and to check things. I've got a picture here of the scientific method. However, the person who designed this beautiful, wonderful picture did the steps out of order. Basically, you come up with a problem. You then start researching the problem. You come up with an experiment that you can use to test possible solutions to the problem. You run the experiments. You collect some data. You find out if the proofs were right or wrong. And then you come up with a conclusion based on your experiment. For the rest of your lives, as long as you're in a school setting, you'll use the scientific method in pretty much every science class you take. And especially if you plan on living your life and doing some kind of science thing, I would recommend social studies, of course, myself. But you'll be familiar with the scientific method.